Okay, so here we go. So 23, solve each by substitution. So if you're going to solve something by substitution, what's the first thing you need to do if you're solving something by substitution?
Make sure that one.
Do what? Isolate a variable in one of the equations. What's nicely? Because that's step one. Step one is isolate a variable. Now, can you choose any one you want? Theoretically, is there generally one that might be the nicest one? Sure. Which one? Y in the second one. So in this case, you know that y is equal to 3x. So then what's the second step after you isolate? So we isolate, and then what's the method called? Substitution. So we take that and we plug that in for y right there, and what do we end up with? 3x minus 4 times 3x equals negative 22. So we end up with 3x minus 12x is equal to negative 22. So what is it? Negative 9x is equal to negative 22. So x is equal to 22 over 9. And then once you get that, how do you find y? Yeah, we already isolated it, so y is equal to 3 times 22 over 9. That cancels, and you're left with 22 over 3. So to state the answer, state it as 22 over 9, comma 22 over 3. Done. Stop there. Yes, Sadea. Okay, fine. So it's coming back good. So on this one, you need to graph, if you're going to solve it by graphing, you need to graph each of those lines. So let's graph both of them. What form are each of those lines in? Standard form. It says by graphing. It says solve each by graphing. You must graph them. If you don't use the method, you don't get the points for the question. Keep that in mind. An answer is better than nothing, but to get anywhere close to full credit, you need to use the method. What form are these in? They're in what form? So when something's in standard form, what do you search for?
The X and the Y.
The X and the Y intercepts. You search for the X and Y intercepts. So when X is 0, what's Y on this one? When X is 0, what's Y? 4. And what about when Y is 0? What's X? So both of these intercepts are 4. So let's say 4 is right there and 4 is right there. Let's just say 4 and 4. Because when you make that 0, what does X equal? And then the same thing happens over there. So what do you do with those 2 points once you have them? You just connect them. Exactly. So there's 4 and 4. So now when you need to find the intercepts for the second one. When X is 0, what's Y going to be? When X is 0, Y is going to be what? No. Negative 2. And when Y is 0, what's X going to be? 1. So you have 1, 0, which is roughly right there, and 0, negative 2, which is going to be right about, I don't know, here. What do you do with those 2 points? You connect them. So let's connect them. And again, what's the limitation on graphing?
You can't tell like the exact.
It's not going to be exact. How exact the answer is depends on how exact you are in your graphing. Was I super accurate in this? Not really. I mean, I kind of did it I did it by estimation, essentially. Now, to find the answer to this, you estimate it by finding the what point? The intersection points. What does it look like that point might be? 2, 2. Kind of looks like it said 2, 2. I didn't do that bad of a job. And how can you check to see if that's the right answer? Plug it into where? It has to work in both. Can a point work in one but not the other? Yes. Like this point right here is on the green one, but is it on the purple one? No, it's not. So you need to test it in both. 2 plus 2 is 4. 4 minus 2 is 2. So does it work? Yep, it does. Again, though, if these were changed by just a little bit, if I changed the slope of one of them, could the answer change into like 20? Like, for example, if you had to graph these 2 lines right here, let's say you did this one by graphing, why would this be a terrible one to do by graphing? Like, not even fractions, like not so 22 over 9 and 20, you have to do it in thirds. Not very nice. Okay, anybody have one?
Yeah.
What's the x-intercept? And Baker, what's the y-intercept? Okay, Chris, you're Chris. Hannah is Hannah. There you go. Anybody have the intercepts for the second one? Hannah, go.
So the x-intercept is 2 from 0.
Yep.
The y is 0, negative.
Correct. So you have those points, you graph them, and then. So for substitution, what's nice about this? It's already isolated. Exactly. So why is that so? 4x minus 2 times what? Equals 0. So that means that 4x minus 4x equals 0. 0 equals 0. What does that mean about this? It's the same line. It's just the same line written 2 different ways. You just plug it in. So this x goes right there. So 5 times what? Y minus 25. Y is equal to what? So 25y minus 25y is equal to 5. 0 equals 5. So what does that mean? Parallel lines.
Okay, I just like that's what I get, and I just
No solutions. Well, I'm telling you now.
So is
Boom.
there a solution?
Kind of looks like this. If, for example, you were to tell it to graph some equations, what form do you have to put them into your calculator? Slope-intercept form. You have to put them in slope-intercept form. So, for example, the first one, if you were to do this, if you were to do the first one, you'd end up with x minus 6. This is question number 1 on the quiz. It was x minus 6, and y equals negative 2x plus 6. So you have to input it into your calculator like that. Now, on Zoom, what's a great Zoom to start with if you have no idea? Anybody know? Well, if you have no idea, Zoom Standard is a good place to start. If you have no idea whatsoever, try Zoom Standard. So let's try Zoom Standard, which is Zoom 6. If you try Zoom Standard on this, and no, I don't know why the calculator still works really slowly, even though it's a program on a computer that's like 1,000,000 times more powerful than your computer. Look at that. You have this graph. You would have gotten a... You would have gotten a graph. Still talking. Hold on. So when you do this one out, if you were to graph this, that would be the graph you get. But then you need to estimate the solution. So the solution is where? It's right about there, which looks like it's about 4 and. So kids, a lot of back talking here. Negative 2. So that looks like what you would approximate it to be. Now, here's where, let's change this just a little bit. What did I say graphing's biggest limitation is? Accuracy, exactly. So if I change it just by a little bit, let's make it x minus like 6.5. Does it become a lot harder to estimate the intercept?
Yes.
Yeah, I could zoom in. Even if you graphed it like this, if I just look at that, is it automatic what you think? Oh no, it's gonna be some weird decimal, right? On your calculator, there's a blue little button above trace right here. Above trace, there's a blue thing called calc. Watch what happens. If I do second and then hit trace, there's a really, really cool function there. What's it called? Look at the 5th one. Intersect. If I go 5, what does it ask me for? First curve. It treats all functions as curves. So you see the blinking cursor?
Yes.
It's on the blue one. I hit enter, and then it has, where's the second one? I hit enter, and then what's it ask me for? The guess. So you move your cursor near or close-ish. It doesn't have to be right on top of it. I'm gonna move it all the way down there. Hit enter. Great. And look what it does. It gives you, look at the bottom. What did it output for you? Whoa, very cool. Now it gave you these decimals, so I changed this just a little bit, right? Again, this was 2x plus 6, and the blue one was y equals, what was it? What was the other one? Y equals 2x, negative 2x plus 6. Negative 2x, x minus 6.5, thank you. X minus 6.5. So it gave us the intersection. Is that pretty cool?
Yes.
It gave us the exact intersection. What's actually kind of even more interesting about this is if you go back to the main screen and type x and press enter, look what it gives you. And if I typed y, where's y here? Y is under, it's blue. I don't know where y is. It's right, wx, y. I'm losing it right now. Oh, there it is. I'm looking at the wrong color. It's not, it's this one right here. Oh, alpha, y. Look what the calculator stored there. Did it store the values?
Yes.
Now, when you see a decimal like this, can you interpret what these are? This is negative 2 and what? 1/3. Do you know what this is?
2/3.
I mean 4. Do you know what that is?
Isn't it like 1/8?
Is it kind of 1/8?
12/3?
12/3, something like that? Is it 1/3, half of a third? What's half? It's a sixth. It's 4 and a 6. 4 and a 6. I think so, right? 6? I think so. Now, let's try this. Has anybody seen this before? X math to fraction. Has anybody seen the two fraction function?
Yeah.
Look what it translated it into. 25/6. Now if I did alpha, so I did y, and I did math to fraction, look what it gave us. Look what it translated the answers into.
How do you put in y?
Ah, it's a green, there's green letters, they're not showing up right here. Press alpha, and then the key that has a y above it. So you can type in y, but what I wanted to show you here is two things. One, when you graph them, what form does the function have to be in? Slope-intercept. It must be in slope-intercept form. And then when you graph it, you need to be able to see the intersection. And then what's the function? You have to use the window, change the window around if you need to. And then what's the function called that gives you this point that you're looking for? What's the function called? Second trace. What's it called right here? Intersect. 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 Raise your hand if you brought your calculator today. Raise your hand if you didn't bring your calculator today. Make sure you're sitting next to somebody else right now and go pair up according to, if you don't have. Okay, here we go. Is it going to show up? Oh, there's one. Nice. Does the second one come up? Excellent. So how many solutions am I looking for?
One.
One of them. Second calc. And I do intersect. Enter, enter, and then enter. It's going to be the guess. Oh, did I actually make something with a nice intersection?
Yes.
Cool. Did I do that on purpose? No, actually I didn't. Awesome. It worked. It worked.